We are doing this morning capacity planning and perf testing. And, morning chaps. So the key for today, well especially this morning, is it's an interesting journey that you've seen so far in the last couple of days where we've seen the configuration, the deployment, the scalability of the farm. So we've seen the various speakers take us through taking from the 2-server farm, expanding it to 4. We've seen Neil take search, scale that out. We've got the whole performance stack on top of that we now need to address, which is, have they really done a reasonable job of our farm? And that's what we're going to find out. We've also got some interesting pieces that we are going to look at, and one of the reasons I wanted to do this over 2 sessions is that as much as possible, I want to try and break it. That's the key. When we're doing testing and performance planning of SharePoint, sometimes we can run several key tests and we can go, oh, that's a win. And we walk away and we kind of go, right, we don't need to check anything else. But 3 months down the road, you're still getting a lot of complaints, a lot of people saying it's slow, and instantly people will then start thinking it's SharePoint. And you're saying, well, no, because 3 months ago it was fine. And so that's what this session's all about, is looking for some key indicators that's going to help us to address those problems. So I'm going to try and throw in quite a few little niggly tests to break it during the 2-hour session. Interestingly enough, there's no PowerPoint specifically that I'm going to use. This is demo heavy. I don't like PowerPoints talking about CAP planning because the best way to do perf and CAP planning is to do it. So lots of hands-on we're going to do this morning. So I've got to start, I just wanted to make sure we've got something to start hitting, right? So the first thing that I'm going to start talking about is the tools that I'm going to use to do this demo. If anybody's ever seen me talk about capacity planning in the past, this is when we as IT pros are going to open Visual Studio. Morning, Ben. You can say hello. You can't talk. Are we going to do like the? Are we going to do the Penn and Teller sketch that we were going to do?
I was sick last night. I took cold. Can't wake up.
Oh, you can be. Okay, so you can be. Which is the one that's silent in Penn and Teller? Is it Teller? Yeah, you can be the other one. So what we're going to do is we're first going to look at the tools that we're going to use. And Visual Studio is one of the best tools that we can use for CAP planning because it has the ability for us to do tests that's going to hit the SharePoint environment. It has the ability for us to do security mechanisms so we can bring in user accounts and Active Directory people so that we can test against that. It has the ability for us to do data source mining so that we can say to the capacity planning tests that, let's say, for example, we want to go and import 5,000 users from our Active Directory through a CSV file, use it as a data source, and hammer our SharePoint environment using those accounts. We're actually going to show you a demo of doing something similar to that, where we're going to use a CSV file used for search query terms and start using that as a data source to do capacity planning against it. And so that's one of the tools that we're going to primarily use. But there are other tools out there that you can use for capacity planning to help you. Things like Fiddler. How many people here have used Fiddler as an IT pro? Fantastic, everybody. We all know the use of that tool, right? The tool to be able to tell us what's actually going on from a client connectivity perspective into the servers. One of the things that a lot of people don't realize about Fiddler is that it has the capability to export what it's found into a Visual Studio web test. So we can take Fiddler, use what the client is seeing, and then export that result set into the test that we're going to build for SharePoint performance. And so these little tools we're also going to fire up and show you a bit about it. Which Ben's doing now. See, this works really well, Ben, doesn't it? I like this bit. I like this. I can just keep talking and you just keep doing. And yes, it does work well as well. Ping. Actually, one of the first things we never do, very often, when we've got performance and capacity planning issues, is think of the infrastructure. All too often we think it's SharePoint. The first thing we should always do when we're troubleshooting performance of SharePoint is not assume it's SharePoint. How many people in the audience, for example, have got environments where you've still got hardware that's more than 2 years old on the clients? 2 years old, right, more than 2 years old. We think that's pretty relative, right? You know, it's fairly new, 2 years old. How many people on a 2-year-old machine have tried to install Windows 7, put all the latest Office tools and various other components, and then found the client to be quite slow? How many times has that happened? Hands up. Right. So, is the problem for capacity and performance of the page loading actually a client issue, not a server issue? We must consider those as part of our performance planning thought process. Can we connect to the servers? What's the route that connectivity is taking when we ping it, when we do a trace route or a path ping? Path ping's really cool. How many people know path ping? Okay, we're slowly getting the hands down. Great. So we've got a few people who know that. So in the command prompt, there's a tool called path ping, one word. And path ping is really good because not only does it ping the remote server, but if there's multiple routes and hops, it will actually calculate what package loss it took whilst it goes through each route. No, that's path ping. Path ping will do both. It will ping it and tell you the packet loss as it routes there. Trace route will just show you how it got there through the route mechanism, right? So, should we bring the slides up, Ben, just so go through what we're actually going to cover here? I know you got them on that machine. Okay. Oh. Sorry, you have to press the Z button. So let's have a look at the farm architecture. Should we go through that one, and then we'll look at the capacity planning itself, and then we'll do some testing tools. So here we go. This is what we've currently kind of looking at, isn't it? This is what we've got in our environment. This is what we've built so far. It kind of looks quite scary when you look at it like that, isn't it? This is what we are at. This is what our little server rack's buzzing away with. So we've got our various clients. We've got our domain controller, our mail server. We've got SQL mirrored. We've got our 2 SQL mirror instances. We've got Server 01. Now, Server 01 is what we're going to use as our Visual Studio testing box. That's going to be our primary machine that's going to drive the testing tools. We've then got Server 02 and Server 03, which are there for Spence and Kimo's session on the cloud stuff later. That's going to be very cool, by the way, assuming it all works. Because obviously that's all cloud. We're hopefully... shall I spoil their thunder? We are literally going to try and do it live to the cloud today. Lock, stock and barrel. We might miss the barrel, though. 0102, SharePoint web front ends. So, in our capacity of SharePoint, we've identified that we're going to have 2 web front end servers that are going to be the connection point for the users. So they're going to be coming into our SharePoint environment through the 2 web front end servers that are load balanced. For the purpose of today, we are using the Microsoft load balancing service, which is fine for a lot of companies. For other companies, it's not powerful enough or efficient enough or redundant enough for some companies who might use hardware load balancing. But we're going to use the Microsoft load balancing in order to direct the traffic on those 2 servers equally between the 2. It's never always quite equal, though, load balancing. There's always kind of a slight percentage change.
See if my voice is working. Kind of.
You getting there?
Is that okay?
It's working.
So when you start testing, and I'm a little sick, so I apologize up front. Just remember that there's really 2 major components to the web service, the web applications, and where that performance of what you're testing. So here, for example, we tried to not make this hard. Application pool is one of the primary things we're testing, and that's on the web server itself. So it would be here on 1 and 2. Likewise, the SQL databases are down on SQL Server. So especially with new SharePoint admins who have not done a lot of performance testing before, those are your 2 primary target components in the beginning. There's lots of other things we'll test down the road. We'll show you some search testing and other things in session 2 today. But at the basics, these are the first things we want to get running well.
It's a really good point, because when we look at our web front end servers and we're planning our hardware architecture, one of the most common questions is, how much memory, for example, should I allocate to a web front end server? And inevitably, the real discussion isn't just about how much memory we're going to have. It's those web applications that we're going to be running, because those web applications are going to be using the application pools as its resource pool for those connections that are going to come in from the client. Of course, another important discussion in that side, talking about the databases, by the way.
What did I say?
Databases.
Databases, sorry. Still learning the right process.
I'm trying to teach Ben English this week. It's not working very well. So, but when we think about it, if we've got like 2 web front-end servers that all the clients are connecting to, but then we've also got various service applications like search, like performance point, BI, all these kind of Excel services, well, it's not necessarily the client connections going to the web front-end servers where that activity is taking place. In our scalable architecture, we've now got 2 servers in the application tier behind the web front-end servers.
Huh? I have that too, mate. So I'll give you a quick overview into that service application architecture. We don't have a lot of time today to talk about farm architecture. But essentially, I don't know why that wrapped on me. Essentially, every time you see on TechNet or MSDN, it talks about a service machine instance. All that is a service that's turned on. So don't make that too hard. It means you've gone into services on server and you hit start. The service application can run across at least, it has to be 1 box, but generally we'd run it across 2 boxes. Why am I running across 2 boxes, Steve?
Why would you run on 2 boxes?
At least.
At least. Yeah, because we've got the proxy, right? You've all learned about the proxy. One of the things about the proxy in the service application layer is so that we can have multiple servers that say if one's not available, it's going to switch to the other one. And the service proxy is going to tell the connections which servers are hosting that particular application service. So if we've got all of this stuff running on 1 or 2 servers in your environment and that's it, you've potentially got a bottleneck right there, depending on how busy they are. So one of the reasons why Ben was saying 2-2-2 is because 2-2 gives you the best combination of performance and resilience of your server architecture. So what else are we going to do? What else are we doing today?
Overview and then get into it, I think.
Yeah, let's just get into it. I don't want to spend too much time going through the bits and bobs that we're doing here.
I'm going to do 1 slide here, just a common sense slide I'd like to talk about. And that is when you look on TechNet about the maximum capacity. So how many documents can you have in a document library? 30 million. Yeah, very good. And what's the default upload size of a document? Right. So could you? What's the largest document upload size? Wow, you guys are well trained in here. Yeah, 2 gig. That's right. Now, do you think you can have 30 million 2 gig documents in a single library? No. As I increase the upload size of my documents, the number of documents in a library must decrease. So that idea or that concept goes across the board in SharePoint. You can't hit the boundaries all the way across the board. You can have how many content databases in a web app? 300. What's the maximum size in a web app? I think now it's like 4 terabytes. But would you want 300 4-terabyte databases on a single web app? Well, of course not. So just remember to use some common sense. It goes a long way.
But going back to your point earlier about the databases at the back being part of our key performance test area, you know, it's all very well and good saying that the performance of our web front ends is good. So we're looking at the statistics and looking at the concurrency and the requests per second. And we'll talk about requests per second in a bit. We'll explain this a bit more, what we're looking for. But the web front end servers could be performance testing really well. But then we look at what's happening in the back end on the SQL side, and where we've got other applications like search, like BI, all hitting the SQL server as well at the same time as people uploading big documents and working with documents. That's where your back-end performance can get hit. And one of the things we found in 2010, absolutely across the board, was the minute we started using 64-bit architecture with properly allocated memory through the application pools spread across the different service applications and the web applications, we saw SQL start to get hammered. Because the 32-bit architecture previously, we had to have lots and lots of servers to get that same hit on SQL. SQL now is becoming one of these services as part of a SharePoint platform where the argument is now very valid in your business to have multiple SQL instances to handle the different service application model. So don't start assuming that you can just throw memory at a single SQL mirror and you will get all that capacity performance. So if we are going to have, you know, a scenario where we have got potentially a group of site collections that are going to be working with fairly large documents, you know, we may want to go down the route of having those databases stored in a different SQL instance that's designed for that purpose, so that we can have the collaborative use of all the other stuff in another SQL instance that's optimized for that type of traffic.
before we switch off, because I'm going to reference this file later, I'm going to go ahead and put it up here and show you. The load test repository, it's a SQL script that will allow you to build the load test database. It is on the Visual Studio machine and not on the SQL machine.
Yeah, so what we're doing
here,
so let's explain what we're doing here. So this is, we're going to start setting up the test rig. So we're going to take you through the process of actually getting the Visual Studio set up so that we can start storing our tests that we're doing. Because, of course, one of the things we want to do when we start capacity planning SharePoint is we want to see the results, but we also want to keep them and share them and compare them so that we can do comparative testing, performance over time, analytics against it. So in order to do that,
the demo failed next door yesterday because they didn't create the database.
they didn't create it first, right, correct. So in order to do that, we need a database to store it.
Ours won't fail.
No, this won't fail.
Now let's get over to it. We have a lot we want to do here.
Yep.
I was taking notes.
Very good, very good.
English I'm going to learn. This is what this is for here. I've got a long list. So here I've got Fiddler going on and looking at sessions. When you come into Fiddler, you can just do an export sessions here. You can see. And we have several options here, but the one we're interested in today is the Visual Studio Web Test. So you can go into Fiddler, look at traffic, and do an export, and then import that into Visual Studio and use those to actually do web and load performance testing. So kind of cool for you pro Fiddler people. I like Fiddler. It's lightweight. We use it a lot.
That's a really good point. It's a very lightweight tool, so it's a really good one to have on your testing box.
So if you're on a client site and you just need to capture some traffic and take a look at it, if they've already run those tests via Fiddler. The other nice thing with Fiddler is it can de-encrypt SSL. You can have an endpoint stop at the browser that you're testing with Fiddler, so you can get into SSL traffic and test your traffic with Fiddler. So another big advantage, especially with like our government clients or banks.
Yeah, because let's think about it. If we're doing SharePoint extranet, got a web application doing HTTPS, we're going to want to test against that as well. Also, did Spence do this in the Kerberos session, Fiddler? Did he show the... did he use Fiddler for that? Does anybody know? In the Kerberos stuff? Yeah, so again, we can use it to inspect traffic for other things, not just performance, right? It's a very useful tool. So intranet should be working. We've already got that. So you're going for a test on Fiddler with it. Mm-hmm. So Ben started to get Fiddler. It was working. We had it up earlier. We saw the 3 people. I've noticed you've gone to finish on your language set. Is that deliberate?
No. I speak.
I think Kimmo's trying to hijack it.
No. All right.
There we go. As you can see, we've pre-populated this homepage with lots of new information. Today's not about... What we're showing you today is irrelevant whether we've got document libraries with 1 million documents or 500,000 or 50,000 or 5. Today's not about that. Today's about doing it right in the first place and then getting the results to test it. We've got enough to break it, don't worry, if we really want to. So did you have Fiddler running on this one?
Mm-hmm.
Let's change this language over to English.
I did.
Is it flip back again?
It keeps flipping back on me.
Oh, okay.
And,
so go on.
And I don't know the Finnish keyboard.
So when we hit a site using Fiddler, one of the things that it's going to do is it's going to come back and tell you not just the authentication process that it did, but it will actually capture what it's been doing on the page. So if, for example, you went to SharePoint and did a search, Fiddler will capture not just the fact you did a search, but it will also capture the query that you did within the search string. So you can still export things like a query term from Fiddler into Visual Studio. So are we going to go for the set up the database now?
Mm-hmm. It keeps flipping to finish, no matter what I do.
Yeah, don't worry about it.
Really, all right.
We'll be fine. Okay, so don't be afraid of what you're about to see. It's just another tool.
And this is for IT pros. essentially. It is. Or for developers, either one.
Yeah, a lot of IT pros don't realize just how useful Visual Studio can be in your weapons tool set of performance testing, capacity planning.
And I love developers. I said it today. You heard me. I love developers. So when you go in here to create a new project, you should see one called Test. See there, the Test project. If you do not see the Test project, you have the wrong version of Visual Studio, as in Professional. Visual Studio Professional will not be able to do what Steve and I are going to show you today. You would have to upgrade your MSDN to, I suppose, the Ultimate Edition. The upside is they have lowered the price tremendously. And I don't know what the poundage is, translation or euro, but it is considerably less than it used to be. Especially if you put this against tools like Load Runner or something that's 100,000 pounds. You're talking more like 1,200 pounds, if I had to guess. So something much, much more reasonable.
Also, whilst you're on that page a second, Ben, because obviously we're going to set up the data source first, right?
I was going to do it after.
But you see that location there? Obviously, by default, it's trying to put it in a C drive. One of the recommendations I would always suggest is use that as a map drive rather than a local drive. So have a central storage for all your project files to go into rather than your local test rig. And so we can put that to a shared drive if we so wish. And when you see things like SharePoint in the top left-hand side, that's not talking about SharePoint load tests. That's referring to the development side of the SharePoint classes and actually creating your SharePoint web ports, etc.
So we've created our project. The first thing I usually do is I just go ahead and get rid of the unit test. We're going to be no unit testing today, and so I just want to just delete that. So right-click Delete. We won't write any code or any scripts today. Just so something to keep in mind. We'll be just using the UI the entire time.
Yeah, one of the things that the reason we're doing that is because we don't need to start with complex testing. That's not the starting point. The starting point is to get a good baseline, right?
How many people here have used Visual Studio before? So most people.
Awesome.
Okay, makes life good.
Very good.
Very good. The first thing we're going to do is we're going to create and attach to a database where we can store our results. This will allow us to do testing several different ways. We can test a web server with 2 CPUs versus the same web server we can reprovision in VMware or Hyper-V, with 4 CPUs. And then we can compare the tests and see where we're getting our sweet spot or the best efficiency.
Right.
So first I'm in Test, and I'm going to Test and Manage Controllers. See where I'm at? What we'll do here is connect to a loads results store.
No, we can't yet.
And what's that?
We can't yet.
Yeah.
Did you run the script?
No, not yet. But I was going to show them where this is at. And then you select the database. So,
It's the weather, mate.
it's just
I know I promised you sunshine, but I lied to get you here.
beautiful. And which one we're on? SQL 01?
Yeah. So this SQL file, that one that Ben was showing you before, the one that's stored in the installation files of Visual Studio when you first install it in that IDE folder, in that SQL file that we're going to take it and we're going to drop it into the SQL server and run it on the SQL instance, so that's going to create that load test database with all the parameters it needs in order to store it. Just password.
They changed it?
Yeah. It's not a security session.
Yeah, no, I got it.
Actually, yeah, that would be quite funny, actually. We should break all the passwords for the next guys. So this database is not going to be particularly busy in the sense that it's not going to be, we're not hammering this database that we're creating. It's purely a storage location for storing the long-term results.
And that is over on, what's the workstation name?
01.
SRV, SVR?
SRV01. Yeah. SRV01, that's our testing box. So this is the box that's got Visual Studio installed, right? So Ben's going to take you to where that SQL file is so that we can create it.
I can never remember if it's in program files, x86, or program files. I did that just to show you guys so you would feel better about it, see? And the file we're looking for is loadtestrepository.sql. You'll see it here. See where I'm at. So all we do is simply open that file and execute. So this is going to build that database already prepared to wire up to our Visual Studio load and web test. So very simple. You see how I did. I just connected to my Visual Studio testing machine and grabbed the file directly from there. We go back now to our server, and we can put in our SQL server. Do you know where they're at on the mirroring part?
Oh, the instance that you put it on?
Yeah.
Yeah, so if obviously you're going to need to make sure when you install your SQL database that it's not just a question of location, it's also a question of access permissions. So the person who's going to be doing the load testing, that machine, that client that he's running that's going to access the database has to have access rights to be able to go into the database.
The safest way is that wherever you're logged in here as on this Visual Studio machine, just be DBO on that load test database. You don't have to be. You could sort out more granular permissions, but that's the best way. So I'm going to do is just test my connection here. Test connection succeeded. So we now are configured here to store all of our results in a database. One other thing we don't have time today to look at, but you could also add agents. So we could continue to add machines, Vista or Windows 7 machines, that act as agents for this controller. So if you need to generate 100,000 packets, right, 100,000 requests per second, you could scale out and add 10, 12 additional workstations that are generating traffic. One common mistake we see when testing hardware is that we've gone out and built this SharePoint farm that has web servers with 16 gigabytes of RAM and these uber big SQL servers that are massive. And then we sit down with like a 2-year-old Pentium 4 and try to test these servers. And there's nowhere near enough hardware to test it with. Our example today, we're using a server to do testing. It's very, very common in real world to provision an entire server or two to do your load testing with because you're trying to simulate hundreds or thousands of concurrent users. Microsoft recommends that you have a core and a gig of RAM for every 1,000 users you're simulating. Our experience would say that's probably really close to about 500 users. So every 500 users, you need a core and a gig of RAM and lots of network.
And that's what you need to think about that when you're testing. It goes back to that client connectivity. It's all very well and good running a load test on the server hardware directly, and that's all you're testing. But by using the agents, you're able to then simulate real network traffic as well, rather than trying to simulate network traffic.
They require an agent license. His question was, do they require a license? It's an agent.
But if you've got the Ultimate Edition, you get agents as part of that install. But if you're going to deploy it, yeah, you're going to have to be covered as the cows for those as well, across those client machines.
The great thing is, it isn't like previous versions of Visual Studio where I had to load the entire Visual Studio on those agents. Now I can load just a piece of agent software, run a PowerShell script, and wire back.
Yeah, these are not, you don't have, if you've got 10 agents, they're not 10 Visual Studio package licenses you're going to need.
It's very common. It's the IT team we're putting these agents on, right? We're putting on the IT members' computers while they're at work during the day. When they go home at night, we fire all those machines up and use those to test with. This isn't necessarily a dedicated test rig. You can turn this agent off and they can work on it during the day. Yes. Yes.
Yeah, for the concurrency, you mean? Yeah, if you've never seen it before, if you're going to start testing a lot of connections, you're going to need to add the feature pack that Microsoft released to update the concurrency connections that you need for the over 250 concurrent connections. So there's an additional feature pack SKU that you have to then light up, which will allow you to run over 250 concurrent users at any one time across one or multiple agents. So yeah, you're going to have to get hold of that. If you've got an MSDN account, you'll probably find you've already got it. You just don't realize it's there. You should go into your license keys, and you'll probably find it's actually there already.
Let's go ahead and create a test. So the first thing we're going to do is create a simple web test. Over here in my project, I'm just going to right-click, add new test. Now you could come down here and add web performance test directly, but if you do that, it's not going to allow you to name the test. So I always just grab new test. And we'll call
So this is a web test. So what we're doing here is we're actually going to simulate a user doing an action against our SharePoint environment. So we are going to be pretending we're doing something on the browser. This web test is going to be capturing that information. Absolutely. Yes, it will capture everything that's happening at this junction between your client and the server connectivity. If you so wish, you can actually get even cleverer, because we could actually get some developed code into the web test, so that rather than just simulate a specific action, we could then interject more actions within that. So for example, what if we wanted to test consequential creation of my sites, and then people doing some social pieces on top of it? We could actually simulate that as part of a structured code-based test. So yeah, we can do that as well. So Ben's gone and hit the home page, right? So let's, have you captured that?
I'm paused still.
Huh?
I'm paused.
Oh, you paused, okay. So let's
So as soon as I open my recorder, the first thing I always do is hit pause, because I'm going to go browse to exactly what I want to test. Once I'm on that page, then I'm going to go back and start recording again.
And that's really important, because what you don't want to be doing here as a test is just create one test that you're just randomly browsing SharePoint thinking that, oh, this is going to be really cool. Because what it's going to do is, on the left-hand side here, you can see that it's captured what's required by the user to access that page. If you were to say, right, I'm going to log on to SharePoint, I want to go to that team site, I want to upload a document, it's going to capture everything you did from start to finish as a user. And so therefore your load test won't be actually useful in the long term, because it's got too much stuff in it to be able to combine it into a short piece of a test that you want to activate.
Yeah, the only exception we've ever had to that was a long usability test where we wanted to record the think times of users. Yes, they were thinking. And so we went through a scenario or a script that captured the timing. They go to a library, they look around for the managed list for 8 seconds, I don't know. Then they go into library settings and they go to advanced, and then they make a modification. So we could grab a larger test if you had some specific scenario. Pretty good, eh?
Very good, very good.
It's scenario where we're at, but I of course, I'm learning my English. Scenario.
And that's really important, because it's no use just creating these tests and then saying, well, let's simulate our 1,000 users, which obviously we don't have 1,000 concurrent people on at the same time, but we want to simulate that traffic hitting our web servers at the same time. But they don't all do that, do they? If everybody comes in the morning, everybody doesn't log on and goes to the home page instantly within a 2-second time period. People get there, they have their cup of coffee, they fire it up. How long do they stay on the home page? Do they read the news of the day? Do they then click and go somewhere else? Do they go to their My site? So these think times that Ben's talking about is really important to understand how our users actually access the network in the first place. Where do they commonly go? Where do they go after that? And what's kind of the core period that over, I don't know, maybe 10, 20 minutes that all that happens. And think times enables us, if we know what those think times are, we can build those gaps into our load test later, so that when we're actually testing all of this, we can say, have that 5-second gap between every connection that you then go off as the user. So we can simulate the users actually waking up in the morning.
So from you can see here, I've got the web test created. I'm just going to hit the green button, which is great. It's going to execute my test. We could also see what it's doing in the bottom window here. Let me change the screen around a bit. And a couple of things you'll notice. For one, all the check boxes, circles there, gumdrops are green. So there were no errors in the page. This is really helpful if you already have this running, and most of our customers already have a test rig like this running. So if we're having page problems or server problems, the first thing I like to do is to get in here and run a test, a web test, because those green will turn to red. You immediately see errors inside of pages. And it'll show you not only what the error is, but it'll show you what the resource in the page is that's broken.
And one of the other things that you can do here is, obviously, depending on the type of test we're doing, there'll obviously be some element of authentication taking place. So what if I wanted to run various tests, but against a bunch of users from my Active Directory? So I wanted to actually, rather than keep connecting as a single user, I wanted to code in to the more advanced web test that I want to go to the page as Joe, and then as Fred, and then as Barney, and then as Wilma. I'm seeing a theme developing. Anyway, so rather than just use it as a single account, what we could do is we could point that connection to a data source as a CSV file that could have all of our user accounts listed, and it could then rotate through that list. Is anybody familiar here with the CSVDE export in Active Directory? Hands up if you know that one. Okay, not many of you. Okay, so Active Directory has some really cool little tools in the command line that you can use to export information from Active Directory. So CSVDE is a little command that you can use to export all of your user objects into a CSV file. Take that CSV file, bring it over, amend the passwords, etc., whatever you want to do with that, so that you can then point this as a data source to it. It's a really nice way of doing that.
What we'll do here is I scroll down through this. It'll show you all the components in the page and their individual load times. So that can be very useful, especially if you have a dodgy web part or users put a 2 megabyte file. I mean, I know they would never do that, but it does happen, right? And we can, just the first thing we do is take a look. So if I have nothing but this one web test, I'm working with the server farm, I have a really valuable tool already at this point. So let's run this again. We saw initially the total time was, that's pretty fast, Steve, but a third of a second. So let's run it again and let's see.
Well, this is the problem we're going to have, isn't it, breaking this thing?
And now we're down to, where is it at? Is it still down to is it set backwards, eh? I'll ask here. So you can see our request time, total time, response bytes. You know, 143K, that's not a bad response byte. What would be bad?
When would a user start complaining, do you reckon?
I mean, it's a function of both the bandwidth, the connection they're on, and the size of the page. It is super, super common for us to, the first time we run this test, to see this page 2 megabytes. 2 megabytes, and I can't make that up. Because we've just had graphics that were users, a lot of times these were not web developers, right? Because SharePoint's easy for everybody. All you have to do is edit page, upload picture. So these pictures are not optimized at all for the web. So they've taken their print art, the stuff they would lay out on this print art, and they've uploaded that into the picture or web part, and that's what's on their page. And it's a 2, 3, 4 megabyte file.
How many of you have seen that happen in the real world, where people have just put massive content on a page without thinking about it?
So the great thing is, the first thing we're going to see is total bytes, and you're going to be like, they're smoking something. So let's go down here and let's find it, and it'll show you exactly where in that page. And see, you don't need to run a load test at this point. You've probably fixed the bulk of your immediate page problems by just identifying, we call that a OHS error. Do you have those here? Operator headspace. So they're OHS.
So what you've got to think about here is when you've got an issue being reported back about slowness of the SharePoint environment, this is a key test that you've got to think about, because if they're starting to say, oh yeah, it's really slow, you know, the question is it a particular page that's really slow? Are we seeing a common theme of a particular place that everybody's going? And then we could have a simple web test that we've got and then just run that and just see what the results are. It's a really good way of us finding out the reality of that page and what's going on there. Of course, there's a developer dashboard as well, right, which we could also activate.
So now I'm just going to also run a query test. We're going to get a couple of different tests in here we can play with for this session and the next session.
Oh yeah, we've got a CSV file for this, haven't we? So remember I was talking about the data source to point it to a CSV file? We're going to do that now.
So what I'm going to do is I'm going to just pause this and...
Oh yeah, we're assuming that Neil's search session worked here. Did it work?
I think so.
Have we got a search center?
All right. So I usually search for something that I know I'm not going to find. I mean, a word that's way out there. I use, my word is Batman.
That's a really good point. Never test always against things that work, right? In the real world, people go for stuff and there's nothing there. We get 404s, right? We get all this stuff returning that actually isn't there. That's as much of a performance hit as something that's found, that's cached. So you have to build in the failure errors as well as the positives. And this dynamic parameters that Ben's getting here after he's run his test, That's looking under the hood of the page to see any code underneath that it needs to think about that is part of the page process. So what if you've got a submit button on there that somebody would expect to press a submit form or some information on that page? That's detecting that parameter so that it can build it into the web test. It knows it's expecting potentially an additional response from the test. So all those dynamic parameters, bless you. So it's got it, yep. So there's the results of everything that it did on that page that Ben was typing in. Oh, you went for Batman. Very good.
So you can see why I there put Batman, because it makes it very easy to pull out here when I'm looking at my script. Okay. So if we would like to change that, and we'd like to have that come out of a data source, what I've done is an Excel spreadsheet, CSV. This could be a SQL database as well. It could be a repository you already have. So what I'll do is come down here in the bottom right-hand corner. You can see here where it says value equals Batman. Batman. And I'm going to come down here and add a data source.
So this is what I was referring to earlier about the user accounts as well. We don't just have to do it for, like, in this case, a CSV file for search terms. Whenever we get the option in a web test to point it to a specific source, this is what we can add to say, don't just take this one keyword that we're defining. Go to a data source, and we're going to have a whole bunch of information that you can now reference as part of this test. So we could do a forms-based, right? Forms-based database. If we want to test forms-based authentication to SharePoint, we're obviously using that against a SQL data source, so we could use that.
So what I did, I just went to the internet and I generated a word list of 500 words, and it starts with A, able, aboard, and goes through something that's Z words. Zed, you like that?
That's very good.
Working on it.
It's working.
Teach me English yet. And there's a little bug in this, and let me show you the bug. Most people in this room will end up using what I'm showing you now. So see how up here in the query string it still says K equals Batman. It's not seeing the data source. Well, once I've defined the data source, I have to go back to Batman.
So with Visual Studio, when you go into you can go into the properties when you do a test. So if you have a right-click on a particular section in the left-hand column, you're going to get the right-click properties. That properties is going to show up over here by default to enable you to go in and define those properties.
I now look at my query string parameter, K equals, and it's seeing my data source.
So you set the data source. So that word list, that's going to point to the data source now as the source of the test.
So we'll test this. We'll go up here, we'll run our query test. Ah, awesome. I have something that's an error. And you can see that it ran a query there, and it was able. So it's going to pick the words in the word list, and if I were to run this test again, it should then choose the next one. Must be that finish. Oh, it's still running, eh?
Did we get an authentication issue on that?
We got an internal server error on the social, on UPA.
Ah, yeah. Just click on Edit Run Settings. Let me do this one. Let's do the Edit Run Settings on the top there. So if you wanted to run this test, let's say, for example, you were trying to create a test and you had some sort of an issue. So notice here that we can change various parameters on that one. So we can do things like simulate the think times, again, where we were talking about, let's add a bit of parameters to that. And then we can change how many runs of that we're going to do in terms of the data source rows. You see that? So if we're pointing it to a different data source, it's going to hit each row one at a time, but we can specify how many of those rows we want to hit. Is it not running yet?
It's a 500 internal server error. That looks ugly. That was somebody else's session. I don't know who did the UPA.
Depends. The UPA one worked, didn't it? Was the use profile service one okay? I don't know. Yeah, it was.
Yeah, okay, that's what we're getting now. We're getting the 500 internal server error on the UPA. But regardless, we're not using it anyway. We're more interested here in the search.
Yeah, we're not winning that one, so we're okay.
And so here's your search response. Don't forget, a lot of warm-up scripts we see, because when I first go to a SharePoint site and I get the delay, what's it doing? We're getting a JIT compile, just-in-time compile on the page. So home ASPX, default ASPX. But remember, the first time we run a search, we have to JIT the results ASPX page. So it's not actually search warming up, it's actually getting that page compiled to where the users are going to go for the search result. So it's another page to add to your warm-up scripts. So after you do an IS reset, add the search results web page as well.
Yep. Yeah, and just like users hitting the home page, how when we first hit the home page without a warm-up, it takes that time to do that first JIT compile process. Search is no different. There's also one for that.
Before we're going to do a load test. I want to do a load test here on end of this session before we get into the next one. We'll get into a lot more detail on the next session.
We've got about 10 minutes on this, I think, right? Something like that.
So what we'll do is this time, instead of creating a web test, we're going to create a load test. The first load test we run with customers is generally very simple. There's no reason for a big complex web test in the beginning. Get something really small like a portal read and throw 10, 15 users at it, and just to find out kind of a baseline of how well you built your server farm.
Baseline is really important. It's no use doing web tests if you've got no idea what it actually runs at in a normal optimal environment with no users on it in the first place. So if you don't run these web tests and these load tests from day one before any concurrent connections users are on it, you don't have anything to compare it against. So it's always useful when you've built your brand new farm to do a simple web test against the home page and get those documented down so that you know what to expect in a normal environment.
So here we're not going to use think times at all for our first test. That's worst case scenario. If you think about it, worst case scenario are users not thinking, clicking as fast as they can. And we do have some users. You ever seen the users? The page isn't loading, and what do they do next? They hit refresh, don't they? They hit the refresh button, and then they're waiting for the page, and that doesn't. It's slow. So what do? They hit refresh again and again and again, like somehow we've created some kinetic energy capture device. So the more you hit the keyboard, we could actually transmit that energy into our data center and create power. And we've solved our data center power problem.
That was the
I said that once to somebody. They were not happy. They were like, I won't say what they called me. So worst case, we won't use think times. We're going to ping the servers as fast as we can.
But we're going to show you how we can edit this. One of the good things about these tests is once we've created them, we can go in and change all these parameters to do other tests.
Do you want to do a constant load at this point?
Yeah, let's just do a constant load. Again, this one here is saying how many users do we want to have running that particular action at that time. Of course, always remember, concurrency is not your total user base. Concurrency is going to be a percentage of your user base that we assume will be doing this task at this time. So on average, in the real world, a concurrency will be somewhere around 10-12% on most infrastructure environments. However, I remember the conversation we were having last year about that company you did the social stuff with, didn't you?
That's right.
And what was it?
And it's getting much worse. So we've seen clients now, once they've implemented the workspace, or they're running Caligo, or they have list synced with Outlook, and all of these offline clients and social features and managed metadata that's plumbed into Word and Excel and PowerPoint, we're seeing 30% concurrency. So the concurrency, as we get more integration with the desktop, the concurrency, we're definitely seeing those numbers go up. And the answer is it depends. But if you've rolled out offline clients to everybody in your company, you can almost guarantee your concurrency is higher.
And now we've gone full circle back to that client. If that client machine is slow and trundling along and it's trying to run all these things, is it SharePoint that's performing badly with the concurrency, or is it their client that's slowing it all down with all these tools installed?
One thing to remember when you're dealing with a user and you have a slow experience is I call it block to browser. So go to the SQL server, the actual physical storage. I mean, when we have performance issues, I'm like, where is your hard drive? Show it to me. And they, I don't know, the storage team manages it. But go actually find that hard drive and then look at all the components from there all the way back to that client's browser. Because any component in that path could be the issue. We see common issues, which are desktop config. It is very common. Auto-negotiate between the servers and the switches is a super common performance problem. Don't use auto-negotiate, by the way. It's commonly the network interface.
Yeah, network cards. If you've got your network cards with all your various switches in the network infrastructure set to auto-negotiate for your speeds, that can cause huge bottlenecks when it's not actually running at full speed between the clients and the servers. We see that a lot. How many people have seen that in here? Experience it? Right. Always worth checking.
So we'll come in here, and for now, I think we'll just run tests based on the total number of users, virtual users.
Yeah, so this is basically saying, you know, if we've got lots of web tests, so a load test doesn't have to be just one web test. We could have like 20 lots of different little tiny tests hitting different places. We could combine all of those into this load test. So what we're saying here is, how do we want to combine those into a logical percentage? So, you know, maybe 80% hit the home page, 10% go and do this team site, and 10% go to their my site. So this is the way that we can sort of change the percentage levels of people running the tests, or the amount of users.
And you can see here we've only loaded 2 tests. Real world, you'll probably have 20 or 30 tests. Really small tests that you can use independently to test functionality in your farm. But we can now use an aggregate of those to do some load testing. So we're just going to do just the portal the home page, intranet home page for now, and that's the only thing we're going to test. If we had multiples, and we will later, we'll get into this in the next session, you can have multiple tests and you can weight which one gets the most traffic. So real world, but portal here would be like 98%. Oh, I'll show you and then I'll remove it. It's more fun to see it. So what I'll do is I'll just add in our query test. Now what I can do is say, you know, 95% of our requests are read, and those 5% are query. As developers more and more are coding web parts that are search-centric based, that's why we want to be looking at the queries. While you may not have users running queries in the web window, what we do get are web parts, like a fixed query web part that's essentially getting results off of managed properties in an index. So it looks like a content query web part when in fact it's a search web part. And that's becoming very, very common, and that's putting stress on the search part of the farm, which is arguably still better than the content database, especially across multiple site collections. That's how we're getting around that issue of multiple site collections, but it will put a lot of stress on the query.
And if you think about it going forward, we are going to start using search and query a lot more in just the way we structure SharePoint environments. So, you know, getting used to adding search query web tests to your other standard web tests is going to be an important part of baselining, so that over, say, a year or 2 years, as we start to introduce more of these query-based web parts or page designs, we can test that baseline and then show the bell curve over time and see it progressing and getting worse, potentially, for the servers, so we can do something about it, maybe offload some of the tasks, which is what Neil showed us, right? Neil showed in the crawl where you could then start moving those components across multiple servers. So we preempt the problem before it starts to happen.
Here we can change the type of network, but for most of our load tests, we're going to leave it at LAN. That's kind of worst case scenario, right? It's the fastest path from client to server. You could, though, if you wanted to get some more granular testing in the future, you could have multiple network types, like 3G, 4G.
Yeah,
4G.
The thing is, though, with that, if you really want to start doing, you really should run it in LAN. If you really want to start simulating traffic across different types of geo-dispersed, you're actually better off getting proper software that can do that for you as part of a simulation environment.
I would agree, yeah, agreed. And in the browser types, generally we pick IE 8 today. 8.0 is the browser type. It does matter, but you do have like the iPhone and you have the Pocket IE, and then Firefox and Chrome. Here we're just going to use Internet Explorer 8 for our initial test. And then here's kind of where we start seeing some of the magic of load testing, because here is where we're going to load the computers within our farm. The first computer that we actually want to add is our SQL server. Do we know which one's active?
SQL 01 and 2.
01. Now, when you add a server, this is going to automatically reach out to that server and pull the counter sets. So what's the first thing you think about right then in security? The workstation we're on right now must be able to see the registry of that remote machine. It must A, have a network path, and B, have permissions to pull the registry. Because it looks at that registry to know which counters it's going to display in these screens. So it works, it is perf monitor, essentially.
Yeah, this is built-in perfmon. How many people in the audience have used performance monitor before?
Very good.
Fantastic.
So here, this is a SQL server, so I'm going to add my SQL agent.
And these counters for SQL are actually given to the performance test tool by the SQL team. So they're the ones who actually provided the counters to measure.
And they're dead on the money. I've never had to come in and edit the SQL counter groups. I will show you how to edit those in just a moment, but for now, let's leave these alone. I'm also going to come in and add our web servers, which were SP01,
01. Yep.
And we're going to do IIS and .NET, both of those. This is SharePoint Web Server.
.NET, the .NET is really important because when we're testing concurrency and the web front-end servers having performance issues, certainly historically in SharePoint 2007 32-bit, this was a big problem where as more requests were hitting the web front-end servers, it wasn't actually the SharePoint piece that was slowing it down, it was the ASP.NET queues that were growing. So it couldn't process the queues quickly enough, so they were just growing in the ASP.NET queue. That's why we'd want to monitor that stuff, because a performance issue might be caused by the very fact that IIS cannot process the request quick enough to pass them to SQL to actually do their job. We don't see this so much of a problem anymore with 64-bit architecture, though, because 64-bit application pools with the .NET framework process it really quickly, and anything with basically 6 to 8 gig of RAM on the front end of servers, you're going to have to do a lot of concurrent sessions to hit this. As you're going to see.
Here where we have the sampling rate, what this means is how often is the test controller going to go out to these servers being tested and pull the performance counters from them. It's not an insignificant amount of network memory or RAM when you're getting a large set of performance counters. You'll see here the default was 5 seconds. I've changed it to 15 seconds. 15 seconds is probably the minimum number you want to use. See, think if you're actually doing 5 seconds. Every 5 seconds I'm pulling counters from the SQL and my web servers. But I'm taking 500 users and just hammering those servers. You're actually skewing your results because you're actually attaching to the same servers. You're using the same network and the same CPU and the same RAM that you're trying to test by the users, and it skews your result.
Yeah, so you are actually becoming the performance bottleneck by running it so quickly.
The best way to do this is to have long running tests for 20, 30 minutes and have the sampling rate at like every 30 seconds. So you have long periods it'll run, take a snapshot of those counters, and a long period will run and take that snapshot again.
And one of the things that I like to explain when I'm showing companies how to use this when you're trying to do load test environments. So it's all very well creating this load test. You know, it's nice, we've got web tests, we're going to have a load test, we're going to run it for X amount of time, we're going to capture the statistics. But you should always think about the what-if scenario. So as that's running over a 30-minute, 1-hour period, there's nothing to say we can't suddenly log on to the search application server and launch a crawl because somebody's decided it needs to be done. Or we've had to reset the crawl index because it's all got corrupt. So somebody's gone there and they've reset the index and they've launched a recrawl. So even though the load test is running over that 1-hour period, we could interject with some manual process that just spikes it and see what we can do at that point. What effect does that have on our servers in our farm through our performance test?
So I've gone ahead and kicked off a load test. This is going to run over the break, well timed. So we have a 10 or 15 minute break. And so when we come back to the next session, this load test will be completed. We'll be able to take a look at this load test. And then we're going to start adding multiple load tests to it. We're going to start taking a look directly at the application and web servers. And then Steve and I are going to start breaking stuff. So, look, it's almost the last day. We get to now break the servers everybody else has built.
Kimbo and Neil would not they're not going to be happy if we break
No,
them.
they will not be happy, but we will be breaking stuff. So come back, and we're going to it'll be all tool, all demo the next session.
Yeah, so we got you through the basics. We're going to interrogate that, and we'll show you what it actually means and what it's doing when we've got back from a coffee break, okay? So go and refuel yourselves, get back, and then we'll carry on with this.